Good afternoon. This is Subhas Nandi, your stat tutor, and we will today discuss a problem on normal distribution. So I will share my screen with you. The average teacher's salary in one state is 35,441 with a standard deviation of 5,100. Of course, we are assuming that the teacher's salary in this state is normally distributed, okay, with a mean of 35,441 and a standard deviation of $5,100. Okay, what is the probability that a randomly selected teacher's salary in this state is greater than 45,000? So I have a bell-shaped probability distribution, and the mean, the center where the peak is the highest, the value on the horizontal axis, mu is 35,441. That's the mean of this distribution, and the standard deviation is 5,100. We want to find out the probability that the salary is greater than 45,000. Okay, so we are going to use TI-84 for this. Okay, we press the second button in TI-84, then verse key is in the third row, second key and then verse key, and then we scroll down to number 2, which is normal CDF. So I show you on the diagram that we are on the right hand side of 45,000 because we want to find out the probability of X greater than 45,000. So my lower boundary is 45,000. And what is the upper boundary? It is a very large number on the right hand side. And very large number on the right hand side, or a positive very large number, we represent the upper as 1, and then we press the second and comma, second button and then comma. Comma is the button on top of 7. Second and comma will give you the E99. So the upper boundary is 1E99. That is 1 followed by 99 zeros. It's a very large number. Then the mean mu is 35,441 and the standard deviation is 5,100. Then we go to PEST, put the cursor on PEST and hit enter and enter. And we will get the answer of probability of X greater than 45,000 is 0.03. Part B of this same problem asks, for a sample of 75 teachers from this state, what is the probability that the sample mean is greater than 38,000? Okay, so greater than 38,000. That means again we are on the right of 38,000. Now we are talking about the sampling distribution of X bar, because we are drawing samples of size 75 from the population of teachers, and we are calculating the mean of each sample. And we know from the central limit theorem that the probability distribution of X bar has a mean, or the center where the peak is the highest, mu X bar, same as mu, which is in this case 35,441. Now, sigma X bar, which is the standard deviation of the sampling distribution of X bar, also called standard error, is the standard deviation of the population divided by square root of the sample size. Now, we know from the previous problem of the population standard deviation is 5,100, and it is to be divided by square root of 75, where 75 is the sample size, to give us sigma X bar, which is the standard deviation of the sampling distribution. And in our calculator, we do 5,100 divided by second X square gives us the square root. Inside the square root, we type 75 and then enter. And the standard deviation of the sampling distribution, or standard error, is 588.89. So again, we want to find out what is the area under the normal curve to the right of 38,000. So we go second verse, scroll down to 2, which is normal CDF. Lower is 38,000. Upper is a very large number on the right hand side because we want greater than. So we type 1, then second comma gives us the E99. Mu is 35,441. This mu X bar is same as mu from central limit theorem, and sigma X bar is sigma divided by square root of n, which we found out as 588.89. So we enter that value for sigma, then we go to PEST, enter and enter, and we get the probability of X bar, that is the mean of a sample of size 75 greater than 38,000 as 6.95 E minus 6. Now probability value cannot be greater than 1. So it cannot be 6.95. It has to be 6.95 E minus 6. That minus 6 indicates the first number 6 is at the sixth place after the decimal point. So the first five after the decimal point, first five places after the decimal point is filled up with 5 zeros and then 6. So probability of X bar greater than 38,000 is a very tiny small number, which is approximately 0. Okay. So I will stop here today. Thanks for listening. And please subscribe to my channel because I come back every week and solve new problems using TI-84. If you have any question or comments, please type it. I'll come back and respond to your comment. Okay. Thanks for watching. Have a nice day. Take care. See you next time.